Hi everyone, I'm Doug Tyson. I know a number of you have been asking about smelling Parkinson's, so I made this quick video here to give you a little rundown about what it is and what I use it for in my classroom, and what other people like about it, I think. So, just so you know, my pedagogical approach has been informed by something I heard a while ago. You can see it down here on the screen. When you look around a classroom, the people who are talking the most, thinking the most, and writing the most are the ones who are doing the most, or who are learning the most, or doing the most learning. And so that's my goal. My goal is to get students to talk and think and write all the time. And whether I do or not is really immaterial. So here's smelling Parkinson's disease. It was created with that in mind. So this is Joy Milne from Perth, UK. She claims to be able to smell Parkinson's. This was just recently in the news. I believe October of 2015. This hit the newsstands, and she made quite a splash. No one thought anything of no one, I guess, imagined that anybody could smell Parkinson's before, but she claims to have this ability. So you can see there are two different versions of the activity. One for first day or any time really. That can be used with AP or non-AP students. The second one is an AP Stats or Stats 101 review, and that's more you'll see it for students who have progressed through the course and know some things already about statistics and inference. So things that you'll need: download the docs. That's number one from my website. My website is mrtysonstats.com. You want to click on AP Stats here, the heading, and you'll see down here there's a link for the docs that I'm about to show you. You should watch the intro video, which is this one right here, so hopefully you're doing that now. But here it is. And then download or preview the news clips, the videos that you'll find here. Video 1 and Video 2, we use those. So let me show you the documents I use. And here we go. So this is the first day. There's a little introduction for students, and I let them know that Joy claims to be able to smell Parkinson's, and I cut right to the video. And so here's the part 1 video. I'm going to play just the start, and then I'll cut right to the end so I don't waste your time. It's only a minute and a half.
Shortly afterwards, he was...
Oh,
Joy
here it is.
Milne first noted something odd about her husband's scent when he was 45. Shortly afterwards, he was diagnosed with Parkinson's. Now universities are testing if it's a coincidence or a newfound precaution. Here's Mike McCarthy from our...
Once Joy's incredible harnessing, researchers supported by the charity Parkinsons.
Okay, so this is the very end. So they've described and introduced Joy and her claim, and now they're talking about researchers who are willing to commit time, money, and resources to running this down and sort of figuring out if she really can smell Parkinson's and how.
Harnessing Joy's special skill. Once Joy's incredible ability had been recognised, she was given by the university a number of t-shirts. Now, half of them had been worn by Parkinson's sufferers, the other half by a control group. She got them all right, apart from one.
That's the end of the video. I want to thank Vicky Greenberg for splicing the video in half. It was very helpful. So I show them the video, and I want them to think about 3 questions right away. Number 1, why would it be important that someone can smell, to know that someone can smell Parkinson's? The idea there is early detection and maybe finding a cure or getting a better outcome for those afflicted with Parkinson's. You should know that students in your class may very well have relatives afflicted by Parkinson's. I've had students in my class, as well as other AP Stats colleagues, who have had parents who have Parkinson's disease. And this goes over very well. It's a serious story, but incredibly interesting for students, I think. And I want students to know that what we do is important. I want them to know that this matters, that we're not just playing games here, but that stats really helps reveal things in the real world. So questions 2 and 3, I'm starting to get students to understand, you know, hey, this is... there's only one person in the world who knows if this is a real thing, and that's Joy. She's the only one who can tell. And she seems sincere and she seems sweet, but you know, maybe she's smelling something different, a chemical or a medicine or something like that, and not really Parkinson's itself or direct evidence of Parkinson's. So it's not that, you know, we think she's this horrible person, but we just want to make sure. There's a laboratory willing to commit a lot of time and money, and a foundation, a Parkinson's Foundation, willing to donate perhaps hundreds of thousands, millions of dollars to researching this. So we want to be sure. So here's simulating the experiment. So I try and help students understand what a null hypothesis is. I tell students to be a skeptic. So the null hypothesis here, I'm not looking for anything formal, stats teachers. I just want, hey, Joy can't really tell, she's guessing. And actually the researchers are hoping to find evidence against that. They're hoping that's not the case. And question 5, the alternative, of course, is that Joy can really tell. She can smell Parkinson's. And so then I have students simulate. So here's where the cards come in. You'll need sets of 12 cards, 6 of which say Parkinson's and 6 of which say no Parkinson's. So just like this, I used a printer and printed them out, but you can have students create them, give them 12 cards and have them write on 6 Parkinson's, and no Parkinson's on the other 6. As a pro tip, I have my sets of 12 color-coded, so I have a set of orange, 12 cards that are orange, 12 that are yellow, 12 that are green, white, and blue. That way, when I go to hand them out to students the next semester, the next year, I can just grab the orange and there's a set. And then I can grab a yellow and there's the set. So you can see, I have multiple sets. Oops, there we go. Multiple sets of multicolored cards, easy to distribute. That's just a teacher tip right there. Okay. So I usually put one set of 12 in front of each student or each pair. This is another modification by Vicki Greenberg. I got to thank her a lot. So it's fun. Have students do this in pairs. Person A starts with the cards, shuffles them up so person B cannot see what's what and doesn't know, hands them to person B, and person B just guesses. Now, person A doesn't tell them how they're doing. You don't reveal until the very end how many you got right. So this was Vicky's twist. As students are handing them to one another, the person who's guessing has to smell. Oops. Sorry. Didn't turn off notifications. Has to smell the card. And that's the fun part. And they're not treated with anything or scented with anything. They're just regular index cards. But it's fun for students to smell, just like Joy did. Okay? So then we make us adopt, and then person A and B switch. So every student in your class gets a chance to guess 12 times without knowing until the end how many times they guessed correctly. And then we go up and each student makes a dot plot of their number correct. And so we go back to the PowerPoint so I can show you what that dot plot looks like. This is a couple of my classes so you can see a picture here. And it's rare, but once in a while you might get a student who gets 11 out of 12. And if they do, have your students use like a red dot for 11 out of 12 or some other color. And as a stats teacher, essentially what this is doing is shading the tail if they get 11 or 12 right. So as good as Joy or better. And everybody else uses some different color. And you see here that it was green for my students. Okay, so that's pretty cool because you're getting at a p-value even though they don't know it. So, and then number 8, I said, hey, she got 11 out of 12 right based on the small scale simulation between you and your classmates. What proportion of simulations, what fraction, they'll need a little help with that maybe, got 11 or 12 correctly identified, 11 or more correctly identified, assuming that we're just guessing. Here you can see, I think this is 1 in 60. I think I had 2 classes do this or something. I don't remember off the top of my head. So they can calculate that. It might be 0, which is a good chance to ask students, so is it really impossible to guess 11 or 12 right out of 12? I mean, is it impossible? And they should say no, of course. That if we did it long enough, eventually somebody might do that. And so the key is no one knows except Joy whether she can really tell. And the only way that we can make a decision is to look at the evidence that we have about her ability. Really, actually, the evidence against guessing. That's really what we're looking at. And so here I tell them, hey, this is p-value is called probability value, and we just calculated that. How could we improve our estimate? And usually students will tell you, do it lots more times. And we're just going to keep simulating. And so here's where I say, oh, that's good. Do it, each of you, like 2,000 more times. Go. And of course they can't. So go to this website, staplet.com/SPA. So if you get mixed up, just go to staplet.com. So let me just do that so you can see. And there's two different kinds of applets here. The first set, Statistics and Probability with Applications, 3rd edition. That's the one you want to click on. And you want to choose one categorical variable. And it's loading. And so the variable here is decisions. So correct is the first category, and there are 11 correct when Joy did it. You're going to put in Joy's results first. Incorrect one time, and click Begin Analysis. Here's this bar graph. She did very well. You can look at frequencies or relative frequencies, and you can see the frequency table down here. But we want to go all the way down to perform inference now. And so go down with this drop-down menu to simulate the sample count. We want correct to be a success. This you're probably just going to have to talk through with your students, especially if it's first day. Simulate the distribution of the sample count for samples of the original size, assuming that the true proportion, so the true ability is 0.5 to get these shirts, to guess correctly. And I usually just do one sample and click Perform Simulation, and there's like a blue dot, just like my students did on their dot plot or created on their dot plot. And I can click it a couple more times, and we can watch students, virtual students putting up dot stickers. And so I'll click it several times until we get to 30. Okay, that might be a class right there. But I want to do a lot of times, so let's just go crazy. Let's do it 70 more times. Just add another 70 dots. So down here we see we have 100 so far. And you can see, hey, somebody got a 10. But you know what? I'm not just going to go 100. Let's go 900 more. Let's just go insane. And there's 1,000. Okay? And if I really lose my mind, I could add another 9,000. Do this 10,000 times. The dots are now so small we can't see them individually, so it looks something like a histogram. But there are really 10,000 different simulations, and students can see 11 here and 12 here are not impossible, but they're really unlikely. And there's the key to making our decisions. So I want to count the number of dots greater than or equal to 11. Notice the nice little red flag, just like I put up on my dot plot with my marker. And 26 out of the 10,000. Usually you're right around 25 to 35 out of 10,000 times would you get 11 or better just by chance. Students can convert that into a proportion or a probability. 0.002, 0.003, something like that is what you're going to see if you round it 0.003. And usually students will get the idea, boy, that's a really surprising thing to do just by chance. And so we have, one of two explanations. We're going back to those hypotheses. One of them is she was just guessing. Remember that one. And boy, she pulled a 3 in 10,000, 30 in 10,000, 3 in 1,000 guess, or performance just by chance. She guessed so well, she did, 11 out of 12. And that's not a very good explanation. I mean, it's possible, but it's not very good. And then, of course, the other explanation is, well, she can really tell. And that's pretty amazing. And so we're having them calculate a p-value, and it's possible that she got 11 out of 12 shirts right just by chance guessing, but it's not likely. Very unlikely. And that gives us reason to believe that maybe she really can tell. And here's the fun twist in this activity. And you don't let the students in until the very end. Her one mistake really wasn't a mistake. The 12th person, she told the researchers they have Parkinson's. And the researchers said, no, they don't. This shirt was worn by somebody who does not have Parkinson's. And she didn't back down from her assessment. She claimed that they had Parkinson's. So now you go back and you show video number 2, part 2.
She got them all right, apart from one. That person went on to develop Parkinson's. Scientists and the working...
So that's the rest of the video you can have your students watch. They talk about the hypothesis that Parkinson's might change the oils in your skin a little bit, and that's what Joy is smelling. The bottom line is she got them all right apart from one, but that person later went on to develop Parkinson's. They called the researchers back and said, hey, you should know, I was just diagnosed with Parkinson's. And so Joy knew before anybody else, including the patient themselves, that they were going to have Parkinson's, or at least she was a heck of a good guesser. So really, she went 12 for 12. And usually that's where students go like, whoa, wow. And the researchers talked a lot about how they were impressed by that. And so you can go back to this applet that was open and just change this down here. Let's count 12 or more correct, and this should be 2 or 3 out of 10,000 times would you expect to be right just by guessing 12 out of 12 shirts. And at this point, even my most skeptical students are convinced. If Joy was guessing, she did the performance of a lifetime. Maybe the likes of Usain Bolt, I don't know. But that's just not a great explanation. And all things considered, she can smell Parkinson's is the only logical is the most logical conclusion, I believe. And so that's the end of the smelling Parkinson's. We make a note about what a small p-value is and that kind of thing. So that's my handout, and that's how we do smelling Parkinson's. Some quick notes for you if you want to use it later in the year for AP review. I do the same thing. If you haven't used it with your AP students yet, do it later in the year. Do the same thing. Starts off exactly the same. How many would you expect her to get right if she couldn't smell and was just guessing? How many would it take to convince you? So ask for a decision criterion, a decision rule. And then just push them to do a test of significance. And don't get them to stop and think about conditions. Try to just let them fly with this. Get them to write the null and alternative. They should write, P or pi, whichever you prefer. The true proportion of shirts that Joy could identify correctly would be 0.5. And then just get them to use technology, software, applets or calculator, anything to just get a p-value and make a conclusion, and then ask them why they shouldn't have really performed the test they should have performed, because they violate a common condition for having a large enough sample size for proportions. The most common one is NP greater than or equal to 10 and N times 1 minus P greater than or equal to 10. Some people say NP and NQ both greater than or equal to 10. So we'll say, hey, we can't run a one sample z-test for a mean or for proportion, so we can still run a test and get an approximate p-value by simulation. And that sometimes blows the students' minds. Like, wait, don't we just have formulas? No, we can run a simulation. And you do the same thing. And how can you improve the estimate? You run this simulation just like before. And hey, there's this note at the end that she was really 12 out of 12, not 11 out of 12. Finally, students can actually find the correct theoretical probability to get 11 or more successes in 12 trials when their true probability of success is 0.5. That's a binomial random variable. And so they should be able to calculate that, which is another great review for them. A few final thoughts before you guys get rolling and start this thing. On the review version. So as I said, get them to use technology, do the test quickly, then hey, we violated this condition, and simulation gives us this alternative. This is truly a binomial situation unless Joy was told as she went whether she got them right or not, and I'm not clear whether that happened, so I can't be sure. If it did, it's hypergeometric, but that doesn't matter. The p-values are close enough that it'll work just fine. I've had students check themselves as they were doing the activity, or tell their partner as they were doing the activity, and the simulation still works beautifully. It's not really a big deal. And then lastly, what are we inferring here? Although this is an experiment, really the inference is on her ability. We're really treating these 12 shirts as though they were a random sample, representative sample of her ability. And so that's a really subtle one, and that's tough, but maybe not a bad thing for your students to think about. There's no random assignment to treatments. So I like to contrast my final thoughts of some evidence versus convincing evidence. Right? There's some evidence that Joy can smell Parkinson's, but is it convincing? Is it enough to convince you? And that's, statistical significance. It's an informal way to get it at significance. And then second, you can get an inference on literally on day one, and it's engaging. Students like this. It helps them make sense out of things. That's why I stick with counts, sample counts, and not sample proportions, because that's easy to grab onto for students. And I think Fisher would approve, okay, of this approach. Hey, thanks a lot. Here's my contact info if you need to get a hold of me. Take care, and I hope your year is just outstanding. Thanks. Bye.